Yeah. So I was talking about dplyr. Okay. So in dplyr, majorly we have these six functions. Okay. Filter, select, mutate, and arrange, summarize, and group by. Now, since by now we know the features it has, what filter does, what select does, what mutate does. Okay. One thing that you can ask, okay, because so far we have seen lot of I mean, like one function which works very well, and it's very easy to understand, this aggregate, okay, this filtering, subsetting, this works with the base function. So why do we need a dplyr in the first place, right? The answer is, this grammar of data manipulation is very helpful with the huge data set. I mean, like when you work in the real-time data, when you have millions and millions of rows, this base packages might not come with so many flexibilities and features, but this dplyr will assist you in a very easy and like smooth way. Okay, that is the reason. Okay, so to read more about dplyr, just refer to this art document. Okay, and we'll see some good examples now. So like since we start working with the dplyr thing, so it's very useful to bring some data sets. So I'll do is I'll paste, like post some data on the link, for I'll put in different data sets, which we'll be using for modeling and algorithm implementation. Okay, so you have a good understanding by the time we start with that. I'll also put some data, you can use for like using logics and filtering data using dplyr as well. Okay, so get handy of those data I'll let you know when I post it by today end of the day, right? So to access or the default data set that we have in R. Okay, so we have few data sets by default in R. So if you just type data sets, double colon and tab, so you get a list of data sets that is there in R by default. Okay, you can even use this for learning basic concepts so far. Okay, what we are using is our data called air quality. Okay, if it is again a default data set. So if you uh, like just tab right here, air quality, so you'll get the data, right? Air quality. So let's see what air quality looks like. So you have in air quality, you have five columns. Okay, you have five columns and you have like a decent rows. So 153 rows we have. Okay, this is the data set we'll use for our example now. Okay, so if you want to check the column names, so these are the column names you have. Okay, and if you want to check the head of the data, like how data looks like, so this is the head section of that, right? Now, so the first thing first, filter. Okay, so to understand filter, so I first thing which I always recommend is studying the document. Okay, so document, if you write filter directly, so you might not get a proper uh, output. So because filter is a function under dplyr, this is what it says in package dplyr library. Okay, so if you want to know detail about a function which is under some other package, so in that case what we do is we type the base package first, dplyr. Okay, double colon, and then you can type filter. Okay, what this will do is this will basically search for dplyr package. Under dplyr package, is there any function called filter? It searches for that, and then it will generate the document. So this is very important when you want to know the detail of a function which is under some package. Okay, so this is the way, dplyr double colon, we give double colon followed by function name. Okay, and then you read a lot detail about dplyr which was not available earlier. So what it says is filter is basically used for filtering data. Okay, use function find row or cases where, so it talks about specifically about rows, so I'm trying to filter rows. Okay, where condition are true, fine. Then you have useful filter functions. So what are the functions that you can use? So you have this many all logical operators. Okay, mathematical operators, and you can use that in your deep learning. Fine. So let's take some example. what I'll do is so how do we write it? So we write it like this. We write filter, tab, then data set, like which you want to filter. So my data set is air quality. Okay, in air quality, comma, followed by the filtering condition, the logic. So let's build a logic. I want to filter all the rows, okay, where the ozone value is 24. Okay, this is what my logic will be. So I'll write ozone is equal to 24, right? So let's run this. So you get two rows as output. Okay, and one thing to note, that the output that you get is again a data frame. So there is no changes in the type of the output. So input was a data frame, and the output that you got is also a data frame. Now how will you check it? Okay, so first is like we verified the data, ozone is equal to 24. So you get two rows, both the values are 24. Now we need to verify the return type, is it data frame or not. So what I'll do is I write class, okay, and then put the entire thing in the under class, and then let's check it. So you see the class of the output is also a data frame. Okay, this is the beauty of dplyr, which when you use a base packages for subsetting, this might not be the case always. Okay, but in dplyr, the input the dplyr accepts is a data frame, and the output that it gives most of the time is a data frame. So it makes your life easy. No conversion, no storation separately, no hackle tackle. Okay, so it's easier comparatively. Fine. So we saw one logical operator. This is like equal to. So if I want something which is greater than 24 and ozone is less than, ozone value is less than, let's say 30. This is the two condition which I'm trying to put. Let's run this. Let's remove the class thing. Run it. Yeah. So I have 5 rows now, which satisfies this condition. So the filtration happens so fast, and it gives me everything which is greater than 24, okay, and less than 30, right? Okay. So this is a filter condition. So now you can use like any, you can try your hand on any logics. Okay. Now the second function that we have is called select. Okay. So as I said, this is filtering your rows. Now if I want to work with select, so select basically works with your column. So if you want to know about select, let's write like this, question mark dplyr double colon select. Run this. So you have all the details, and the description says select keeps only the variable you mention. Okay, rename keeps all variable. Okay, so we'll talk about this. Select keeps all the variable you mention. So mention means like whichever variable I want to select. So the parameter sequence remains exactly same. First I need to pass the dataset value, dataset name, okay, the object name, comma, what I want to select. If I want to select one column, okay, I'll simply write in quotes, I'll write the column name, ozone. Okay, so it selects the only column which I have specified, ozone. Okay, if in case I want to select multiple columns, so I'll create a vector, I'll combine it using C function. Okay, and in comma I'll give all the columns that I want to filter out. So temp and day I want to filter out, temp and day, temp and day, right? I'll just run it. So I got output which has 3 selected columns, okay, rather than all. Fine. Now the second thing, let me check the output which you got, is it again a data frame or it got some changes? So the output is still a data frame. Okay guys, now I selected a column, so I want to select a column as well as filter some data as well, right? So how will you do that? This is a task for you. So I'm putting this code in the chat. So look at it. So this basically selects few columns. It selects 3 columns. Now I want to select all the ozone. I want to filter this with this condition as well as select this column. How do we do this? Okay, I need to think about it. Just it's a simple thing, a clubbing two function. How do we do that? Okay, just have a look, and if it's not happening, just Google it. You'll get an answer very quickly. Okay, so this yeah. So okay, let's go ahead, and then we have seen select function. Okay, in select function, we saw how do we select columns, right? How do we select columns? And let's say you have 100 columns, you want to see 98 columns, you want to drop 2 columns. Okay, that can be the case. So rather than mentioning the 98 columns individually, one by one manually, let's drop out 2 columns. So you also have the provision of dropping the columns. Okay, so how do we drop it? So in when we want to drop few columns, so again I write select. Okay, data object name. Okay, followed by the column you want to remove it. So let's say I want to remove ozone again. Ozone. Okay, I'll just write minus ozone. Okay, it will do it. What it will do is basically it will give me all data set, entire data frame with all the columns apart from ozone. So you see, we had ozone as the first column. Now we have everything present here apart from ozone, because ozone is something which I removed purposefully. If you see here, I removed it purposefully, right? If I want to remove one more column, how do I remove it? So you can remove it like if you just put minus sign here. Okay, and let's say I want to remove month. I want to remove day. Okay, so I will remove day from here. Okay, and then run it. Again, it will give me from 6, 2 columns were removed. I'll have 4 columns in my output. Okay, so this is how we do. Let's go ahead and take some examples of select we have seen. Okay, this is how we select. If I want to drop some column, this is how we drop. Okay, let's come to the third function and one of the most
Sir,
important
you
function.
are not visible.
Hello,
Hello, sir, you are not visible.
I mean like my screen is not getting shared.
Yes, sir.
Is it now? Is it visible now? Hello.
Yes, sir.
Okay, fine. So, guys, so what you have missed from where you have missed? Can you tell me? I'll repeat. Hello. Okay, so let me carry on from here, and you will have a recording. Okay, anyways, I'll carry on from the select only. Okay, so yeah, so we were talking about selecting columns, and if I want to, we saw how I can select multiple columns. Okay, based on our need. So how did we did that? We did it by putting the column names. If you can put it in quotes, there are 2 ways. So let's see this first. So what we did is we wrote select followed by quality object name or a data frame name, and in quotes I can write multiple columns that I want to select. This is one way, but you can make it more simple. If you are working like if you want to do it like this will also work. You just need to mention the column name directly without any quotes. this will also work. So let me remove this and run it. So I get the same output. I get 3 columns and all the rows, right? So this is the way for selecting a column. Now, if you want to remove some columns, or like as I said, like if you have 100 columns and out of 100 you just want to see 98 and you want to remove the 2. So rather than going the other way, selecting 98 column, you can simply remove the 2 column by putting minus sign. Okay, so this will remove the column you want to remove it. So let me check the head. See here. So I got out of 6, I got 4 columns as my output. Fine. So so far what we have seen is we have seen filter, we have seen select. In select we have seen how to select columns, how to deselect columns. Okay. Now let's talk about mutate function. Okay. So mutate, what I want to do is basically I have a data frame which has few columns, integer columns. So I want to create a calculated field which will be an addition of temp and month. So what I want to do is, like, let's first discover or mutate. Okay, so you have mutate. So what does the description says? Mutate adds new variables and preserves existing. Okay, it is used for adding new variables, so data manipulation, right? So it is written like this: mutate the data frame object that you want to work on, then what variable you want to create. So let's say I want to create new new demo variable. This is my variable name, and what it will be an addition of temp and month. So it will be a summation of temp and month column of my data frame air quality. Okay, so let's see the head. How does it look? Rather than running the entire data, let's see the head. So it looks like this. So what it does is, so this were my default column which I had, these 6 columns. I created a new column, okay, which is new demo var. Okay, and what it is basically, it's a summation of temp and month, right? So if you see 72, 67 plus 5, 72 plus 5, 77. So it does all my calculation here and in my new data set. So if you want to save this, so if you run a object, let's say data new, and run this, so you have a new data set which is a data frame again. So if you see the class of this, so it's a data frame, okay, and it's a new data frame now. And if you check what it has, so it has 7 columns, 6 old one and the one which you have created. Okay, this is the new data. Okay, fine guys. So we have seen mutate. Now after mutate we have arrange. Arrange is exactly like an it's basically an ordering function. So if you run it, if you want to see few examples, it works in the exact same way like what order and every order does, or sorting does. So it's basically a sorting thing. So I'll take one example of my air quality only, same example. Okay, so if I check the head of air quality, so what I have this column. So if I want to arrange my column month or column temp in any order, okay, so I can use arrange function, arrange, and my data frame object, and I want to arrange it on month, right? I'll just write month and run it. So you'll see you have some order now. Okay, this is the order from small to big. Okay, right, you have some order of small to big. Okay, so this was arrange, and arrange is simple. Now the most important thing that we'll see now, okay, that is called a summarize function. Okay, and before we see summarize, we have something called pipe operator. Okay, pipe operator, which we use a lot in combination with summarize. So you have seen one summarize function that is called, if I want to something, summarize and your data frame object. So it has some, so I want to summarize temp. Okay, so summarize is not working because of character data type here in it. But yeah, so let's see the actual summarize that we are trying here. Okay, summarize. So what summarize does, it is basically RIZ summarize. So what it does is basically based on whatever filter condition you have. Okay, so let's first check it here in dplyr. I have dplyr, and under dplyr I have summarize, RIZE. Okay, summarize is typically used to group data created by group by function. Okay, so group by, like as we have seen in aggregate, it is exactly same. The output will have one row for each group. Fine. So if I have to take the same example which is there in the Excel. Okay, if you can see the screen, yesterday we took an example of a company, and I was trying to group it by company. That means I was trying to roll up my data based on company. Okay, and for each row you'll have, for each company you'll have one row only. So this means that you grouped your data. This is the logic. Okay, now if I want to summarize, so I used aggregate here. If you remember yesterday, we used aggregate here, aggregate function. But if in summarize, what will happen, you can do multiple things. First you can filter it. Okay, and on what parameter you want to aggregate it, mean, average, sum, you can write that, and then you can display it in a, like the output will be again a data frame. So here again the same data set, air quality, I'm trying to pull out all the data of month 5, my first filter. So let's run this and check what is the output. So you have all the data with month 5. Okay, now for this data, this all the data, I want to find only this data, like how many rows we got, 31 rows. Only for this 31 rows I want to find the mean of temperature. Okay, so mean of this column, mean of this column. So I'm doing two things at the same time. First is I'm trying to filter data, which I did like this way, and then I'm trying to summarize this data, the output of this data, in terms of temperature. I'm trying to find the mean of this temperature column. Okay, and check the output, how it looks. This is how it looks. So the mean of temperature of all the rows with month value of 5 will be displayed here. Guys, have a look. If you have, like, because we have seen this so far. Okay, forget about summarize now. We have seen this so far. This is cool for us. This is like, we understand this now. Okay, we understand this now. The concern is the output that we got here. Okay, of like air filter, air quality, month 05. So we got 6 as output. Now if I save this in a separate data set called D, okay, So this is what my uh, data looks like. You have all the data with month is equal to 5. So in total I have 31 rows. So if I count n rows, D, I have 31 rows. Now my second target is to find the mean of D dollar temp. What is my output? 65.585. This is my output. What I did is I did the entire thing in two steps. First, I filtered the data. I stored that in a variable called D. Okay. Then from that D, I tried to calculate the average of column temp. Okay, using mean, and I got this. So what summarize is doing? It is doing the same three steps. Okay, that we did above in a single line. It filters the data. Okay, and then in onward basis you have to summarize it. You write the function here, okay, the column name and the summarize. It gives you the exact same output. Okay, now there are one difference basically. First is the first difference which we saw, that was your number of steps got reduced. The second step, which the second difference is basically, again, we talked about that wherever we use your dplyr function like summary, filter, select, okay, group by, the output is your data frame. Okay, so when we do this, so here output may or may not be a data frame. So here what we see is we got it in a list format. I got the first element of a list. Okay, but when I used summarize function, I got a data frame as output. Okay, so these two are the basic difference. Fine, guys, is it good? Okay, now let's take some more good examples of that will include summarize as well as pipe operator. So pipe operator is crucial. So what pipe operator is, so let me check if you have some document. I doubt, but let me check of pipe operator. No, they don't have any document of pipe operator. Okay, fine. So pipe operator, what it does? So pipe operator is a like above assignment operator that we have seen so far. What it does is basically when we're trying to work in a real data set, so your query becomes huge in number of lines. Okay, so each time you create a variable, assign a variable, again that use that variable, create multiple variables, and it consumes a lot of memory, time, and it creates a confusion as well. So pipe operator comes into rescue. What it does is, so it asks you to write the entire code in a sequence, okay, of down up format. Like what I mean is basically assignment will happen from above. So let me write it. First I will create a variable called like I'll use my object. Okay, so what I'm telling R is, this is my object, I want to use this object in my further calculations. Okay, so I wrote object name, the data frame name, and then a operator. Okay, then I press enter, you get auto indentation. See here, your code will start not from the first place here, it will start from here automatically. Okay, so it says it is a continuation of the code. Fine. Secondly, what it will do is it will you can write any function here. So what I want to do is I want to, in second step, I want to use this air quality to filter data. So I'll write filter. Okay, what I want to do is, here you do not need to explicitly specify the uh, the data frame here, because you already specified one. This is good. If you don't even specify, it will work. So I'll not specify for now. I'll write month is equal to 5. Okay, fine. Now again I'll give a pipe operator. I'll pipe operator. I'll press enter. I'll go to the next line again from second place. Now, out of this filtered data, what I want to do, I want to summarize it. Summarize it. What do you want to do? So I want to first calculate the mean of the column temp, let's say the same thing, so that we get the same output. So what happens, it starts from top. In top, it searches for the object. So the object is your air quality data frame. Okay, so what it will do is, below whatever execution happens, this data frame will be used below. By default, the R assumes that. Okay, then in second line, it goes and checks what is happening. It checks that there's a filter condition which is filtering month. Okay, so you created some output here. So basically you get this output 31 rows here in the second line. Now this 31 rows will go to the next step. It will come here. Okay, and this 31 row will be used for calculating the mean. So it happens step by step. Okay, now let's run this and check the output. So you get the exact output which we saw when we did this. Okay, guys, is this clear to you? This pipe operator. So pipe operator is basically a it's above assignment operator, and it does top down execution. Any questions, guys, from pipe operator? Any question, guys? If you want to put it in chat, please put it. How it is working. Let's take some couple of more examples, okay, of pipe operator. Let's say I'll use empty cars. Okay, now my second example will be empty cars, and I'll check it what I can do here. So now in empty cars, I will put multiple conditions. Okay, so let's start it. So I'll use empty car variable. Okay, I'll use pipe operator. Okay, I'll press enter. Now I'll filter something. What I'll filter is, I'll filter all the cars with gear 4. Okay, gear is equal to 4. Fine, this is my first filter. Then what I'll do is, I can, let me put one more filter here. Let's see how it works. I'll put filter. In second filter, I'll press, I'll look for cylinder value 6 or 4, where CYL is equal to 6 or CYL is equal to 4. This will be my 2 filter condition. Now, if I get this, what I want for all these columns, all these rows basically, I want to summarize with sum of carb, let's say. Okay, sum of carb. Now guys, so let's go through what I did basically. So I took a data frame called empty cars, okay, which will be used for all my execution in below queries. In second step, what I did is I filtered all the data, all the car models which is having gear 4. Okay, I can put all the condition in one filter, but I wanted to create more filters here. I can easily put here, let's say all filter condition here. Okay, but I just, for the sake of elaboration, in second pipe operator, I'm trying to filter the data. So this filter will be implemented only on this filter data, because as I said, the execution happened from top to down. So entire empty car data will be passed on to this query. Now whatever is left out from here will be passed on to this query. Okay, whatever is left out from this filter output will be passed on to this summarize function. This is how it works. Now let's run it. Okay, so you get sum of cars from as the output for this query is 28, right, guys? Okay, so there are a couple more examples. Now, the most important example, guys. So the most important example is this, okay, where we basically take a count. So if I want to see my, to try and understand the question, my want is, my ask or the question is, I want to know how many cars does each category of gear have, like how many cars we have in our data set which is of gear 4, how many cars we have in our data set which is of gear 3, and so on. So basically if I go to my raw data, my raw data is empty car. Let's take a head of it. So my requirement is, uh, let's take a head and let's take a tail as well. Okay, so my requirement is uh, 4, 3, 5. So how many cars do I have for with category with gear 4, 5, 3, and 4? Okay, now how do I do this? Okay, so there is a function here in R, and this is like if you use summarize function 10 times, so out of 10 times, 8 times you will be using summarize function for this, getting the count group wise. Okay, so you can understand the importance now. So let me check. I want empty cars data set. I use pipe operator. Okay, and then in pipe operator, I will use my group by function. I want to group it by group by. What is my what is my group by will be? My group by will be gear. Okay. Okay. Then again I'll put my pipe operator, and in pipe operator I will use I'll use my uh, count n. This is the way used. So what I do is like I use count n. Okay, so first is I passed on this data empty cars and I grouped it by gear. So all the uh, like rows with same gear will be grouped it. Okay, and then I am trying to find the count of each gear. Okay, let's see it run and see it how it looks. So it looks like this. So you can just, there are two ways. This is one way. Let's keep it like this way. And second way will be this using summarize. So I don't write count, I write summarize. Yeah. So this is the two way. So let me explain you the result first. Okay. So then we'll come to the code. Okay. So what was our ask? Our ask was for each gear, I want to know how many car model exists. So for third gear, for 3 gear cars, I have 15 models. For 4 gear cars, I have 12 models. For 5 gear cars, I have 5 models. Okay, so I got understanding out of all the yeah. So I got understanding from this data that out of all the 30 different car models which is available in my data set, what is the distribution gear wise. Okay, likewise you can see the distribution carb wise, you can see the distribution cylinder wise as well. Okay, but this is how you do it. So you get a gear, the column on which you grouped it, and followed by the count. Okay, now let's come to the two outputs. So here the output is same. Let me check. Guys, is my screen visible now? Guys, is it visible now, my screen? No?